Hello all, this is M. Sandeep Kumar and I welcome you back to my YouTube channel Math with Sandeep. We are in the chapter of continuity and in today's video let us discuss about directional continuity. So when can a function exhibit left continuity and then right continuity with examples, and after that we will also discuss about continuity of a function in an interval from A to B. When can I say that a function is continuous in this particular interval based on this sub definitions. Okay, let us start with directional continuity, and if you are new to my channel, do subscribe, don't forget this. Let us start. First let us discuss about right continuity. Okay, when can a function exhibit right continuity at x is equal to a? Dear students, at x is equal to a, if the function y is equal to f of x is such that f of a is equal to f of a plus the value of the function at x is equal to a is same as the right hand limit, okay na, at x is equal to a. So f of a plus means what? Limit x approaches a plus f of x. So if the right hand limit is equal to value of the function at x is equal to a, then we say that the function is right continuous. Okay, graphically if you want to understand, look at this. At x is equal to a, the value of the function is same as its right hand limit. When x approaches a from the right side, as x approaches a from the right side, the value of the function is approaching same number. What is that number? Let it be f of a. Okay now, then we say that the function is right continuous. Okay, if right hand limit is equal to value of the function. And one of the best examples for right continuity is f of x is equal to step x. Okay now, the greatest integer function. So let us check the continuity of this particular function, which is greatest integer function, at x is equal to any integer. For example, at x is equal to 3. Okay, at x is equal to 3, let us find all three values, the left hand limit, right hand limit, and also value of the function. So what is f of 3 minus the left hand limit at x is equal to 3? So it is nothing but step of 3 minus. Step of 3 minus means step of 2.999 and so on. Step of 2.99 and so on is equal to 2, as you know. So our left hand limit is equal to 2. Next, if I find right hand limit f of 3 plus, f of 3 plus means step of 3 plus. And dear students, 3 plus means 3.0000 and so on. And its step value, step of 3.00 and so on is 3. The right hand limit is equal to 3. And what is the value of the function f of 3? Which is nothing but step of 3 exactly, and step 3 is equal to 3. So if you observe, in this particular example, the right hand limit is 3 and the value of the function is also 3, whereas the left hand limit is equal to 2. So the value of the function is not equal to left hand limit, only the right hand limit f of 3 is equal to value of the function. So for that reason we can say that step x is right continuous at x is equal to 3. So what is the conclusion? Step x, our step x is right continuous at x is equal to 3, and this is true for every integer. If x is any integer, step x is right continuous only. If you remember the graph of step x, how does it look like, dear students? 0, 1, 2, 3. For example, just before 3. Just before 3, step of 2.99 something is 2. Correct or not? The step value will be like this. And when input is exactly 3, the step value is not 2, it will be 3. And if your input is 3 point something, the step value will be 3. It goes like this. Right? When input is approaching 3 from the right side, the step value is approaching 3. And even the value of the function is also 3. But what about left hand limit? When input is approaching 3 from the left side, the value is approaching 2. The left hand limit is 2, the right hand limit is 3, and the value of the function is also 3. Since the value of the function is equal to the right hand limit, we say that step x is right continuous at x is equal to 3, and it is true for all integers. When x is equal to any integer, step x is only right continuous. It is not left continuous. Okay na? So I hope you understood this. Okay, let us go with the left continuity now. Let us discuss about left continuity. Okay, a function y is equal to f of x is left continuous at x is equal to a if the value of the function is equal to its left hand limit. Okay, now if LHL is equal to the value of the function, then the function is said to be left continuous. Okay, I'll give you an example. You can take least integer function. So if f of x is equal to the roof of x, you know what is a least integer function? We call it as roof of x or ceiling of x. So I hope you know all these functions and their properties. Let us discuss whether the function is left continuous or right continuous at some integer. Let the integer is 2. At x is equal to 2, what is the limit of this function? Let us see. First let us find left hand limit, LHL. So f of 2 minus is equal to, it is roof of 2 minus. 2 minus means 1.999 and so on. Dear students, the roof of 1.99 and so on is equal to 2. You should have known this. See, the answer will be the least integer greater than or equal to this number. The least integer greater than this number is 2 only. No? So the answer is 2. The left hand limit is 2. Next, the right hand limit, f of 2 plus, which means the roof of 2 plus. And 2 plus means 2.000 and so on something. And the roof of 2.000 and so on, what is it? The integer, for example, if this is 2.0001, the integer, the least integer greater than 2.00001 is what? 3. It is not 2. Please understand this. Okay, now, and at the same time, what is the value of the function? F of 2 is equal to, that means roof of 2. It is 2 only. The least integer greater than or equal to this number is 2 itself. See, in this case, the left hand limit is equal to value of the function and the right hand limit is a different number. So here we have only that the left hand limit is equal to right hand limit. Sorry, the left hand limit is equal to value of the function. It is not equal to right hand limit. Since LHL is equal to value of the function, we can say that this roof of x is left continuous at x is equal to a. That is the conclusion. You can write that roof of x is left continuous at x is equal to 2. Okay, now it is true when if x is any integer. At every integer, the roof function is left continuous only. Okay, so if you need one more example, I'll give you. You can also check the graph of the roof function. You can draw it and you can check whether it is left continuous or not. Already we have done it for greatest integer function. No? For this one, you can try it yourself. I'll give you one more example for left continuity. Here is a simple question. F of x is a piecewise function. Okay, at different domains we have different functions. We have to check the continuity of f of x at x is equal to 2. Okay, first let me find the left hand limit LHL. LHL is limit x approaches 2 minus f of x. So limit x approaches 2 minus, when input is just less than 2. X approaches 2 minus means just less than 2 only. When input is less than 2, the function is x square minus 2. So instead of f of x, I am going to substitute x square minus 2. Now you can directly substitute x value as 2. So we will get 2 square minus 2, which is equal to 2. The left hand limit is equal to 2, dear students. Next, right hand limit at x is equal to 2. So limit x approaches 2 plus f of x. So limit x approaches 2 plus. X approaches 2 plus means x is just greater than 2. X is greater than 2 means f of x is equal to x plus 3. So f of x means x plus 3. And let me substitute x value as 2 directly. You will get 2 plus 3 and the answer is 5. The right hand limit is equal to 5. What about the value of the function? When input is 2. When input is 2, the output f of 2 is equal to 2. So in this case, dear students, left hand limit is 2 and value of the function is also 2, but the right hand limit is different. Correct or not? So in this case, only LHL is equal to the value of the function. Therefore, we can say that, what is the conclusion here? We can say that f of x is left continuous. Left continuous at x is equal to 2. Now, what is the conclusion that we can draw after learning about right continuity and left continuity? Let us see it now. This conclusion is very important. Here is a conclusion that we can draw. Once again, when can I say that a function y is equal to f of x is continuous at x is equal to a? if left hand limit is equal to right hand limit, which is equal to value of the function. If these three are equal, we can say that the function is continuous at x is equal to a. Correct or not? And observe one thing, from these two we can say that LHL is equal to value of the function, so it is left continuous. And from these two we can say that RHL is equal to value of the function, so right continuous. So we can also say that a function is continuous at x is equal to a if it is both left continuous and also right continuous at x is equal to a. So that is the conclusion, dear students. Okay, now, okay, fine. Let us see two examples on the, or one example on this continuity, and after that we'll go with the next subtopic. Very easy question. You can do this. They told us to, they have given the function f of x, and they told us to check the continuity of this function f at x is equal to -2. Dear students, because of the presence of modulus function, particularly the 0 of this particular polynomial x plus 2 is -2, correct or not? If I equate x plus 2 to 0, it is -2. So we are discussing about continuity at that particular number only, at -2 only. So we have to do LHL and also RHL. In case the 0 of the polynomial is -2 and we are checking continuity at some other number, then no problem, we can find the limit directly. But in this case we have to find LHL and RHL because we are checking continuity of the function at x is equal to -2, which is the 0 of the polynomial inside modulus. Okay, now for this reason we are finding LHL and RHL. Let us find first LHL. See here, f of -2 minus. Understand the meaning of -2 minus. -2 minus means -2.000 so on. Okay, now it is a number which is just lesser than -2. Okay, now what happens to the number inside modulus? What is the value of the number inside modulus? What is x plus 2? X plus 2 is what? X value is -2.00 something plus 2. Correct or not? If I add these two, what is the result? -0.000 something. So x plus 2 is a negative number. When I take x value as -2 minus, x plus 2 is a negative number. What is the meaning of it? If x plus 2 is negative, then we should write mod of x plus 2 as minus of x plus 2. Mod of x plus 2 as minus of x plus 2. Now come to this question. So it is limit x approaches -2 minus tan inverse of x plus 2 divided by, instead of mod of x plus 2 we are writing minus of x plus 2. That is a property of modulus, and we already know that tan inverse of f of x by f of x is approaching 1 when if this f of x is approaching 0. Correct or not? If you substitute x as -2 plus 2 is 0. F of x, this is f of x. F of x is approaching 0. Once again I am writing this. We learned this in the chapter of limits. Limit x approaches a, when x is approaching a, if f of x is approaching 0, then tan inverse f of x by f of x, this limit will be equal to 1. So in this case, when x is approaching -2 plus 2 is approaching 0, so it is in the form of tan inverse of f of x divided by f of x. So with minus symbol, this is going to be approaching the number 1. Okay, now so therefore dear students, the left hand limit is equal to -1. The left hand limit is equal to -1. Similarly, if you try to find right hand limit, let us see what is the value that we get. So let me write here that f of -2 minus is equal to -1. The left hand limit is -1. Let us check the right hand limit. So the right hand limit at x is equal to -2 is f of -2 plus. What is the meaning of -2 plus? It is -2 plus 0.000 something, which is -1.999 something. Okay, now 1.999 something. If that is the case, what is the value of x plus 2? X plus 2 is equal to, x value is -1.999 something plus 2. So 2 minus this number is 0.000 something. Obviously x plus 2 is a positive value. Since x plus 2 is positive value, mod of x plus 2 will be equal to plus x plus 2. If it is negative value, I should have kept minus before x plus 2. But it is positive value now. So if I remove modulus, I'll get plus of x plus 2. Okay, now if that is the case, then what happens here? Limit x approaches -2 plus tan inverse of x plus 2 divided by Instead of mod of x plus 2, I am taking x plus 2. Okay, now a small thing is when x is approaching minus 2 plus x is not equal to minus 2, correct or not? Since x is not equal to minus 2, I am taking f of x as this function here. So anyhow, I hope you already know that. Now once again, it is in the form of tan of f of x divided by f of x, where f of x is approaching 0 if x is approaching minus 2. Okay, now so therefore its limiting value will be equal to plus 1. Dear students, I got right hand limit as plus 1. What about the value of the function? When input is 2, the output is minus 1. So f of minus 2, the value of the function is equal to minus 1. In this example, only the left hand limit is equal to value of the function, correct or not? The left hand limit is equal to value of the function. So what can I say that continuity, what can I say about continuity of f at x is equal to minus 2? What can I say? I can say that f is left continuous. I can only say that f is left continuous at x equal to minus 2. So that is the conclusion about this problem. Next, let us discuss about continuity of a function in an interval a comma b. So when can I say that a function is continuous in a closed interval a comma b? Okay, let us discuss about that. First, let us discuss about continuity of a function in open interval a comma b. So when can I say that a function is continuous in open interval a comma b? So obviously, graphically you will understand even better. There are two numbers a comma b on x-axis. So between a and b, you must be able to draw the function continuously. You must be able to draw the graph of the function continuously without lifting the hand. See, I don't care what is the value of the function at x is equal to a. It doesn't matter. I don't care what is the value of the function at x is equal to b. But between a and b, for all these inputs, I must be able to draw the graph of f of x continuously without lifting the hand. If that is the case, I can say that the function is continuous in the open interval a comma b. But mathematically, how can I say? Mathematically, I can say that a function f of x, y is equal to f of x, is continuous in open interval a comma b if, when means you take any number, for example c, between a comma b, you take any number between a comma b, at that particular number the function must be continuous. What is it? When can I say that f of x is continuous in open interval a comma b? If and only if f of x is continuous at every value of x in the open interval a comma b. At every value of x in open interval a comma b, you take any value between a comma b. At that point, it should be continuous. If that is the case, at every point if it is continuous, we say that the function is continuous in open interval a comma b. In another language, if you want to understand even better, let c is a number in the open interval a comma b. C is some number in open interval a comma b. Then, dear students, the left hand limit at c should be equal to the right hand limit at c, which must be equal to the value of the function. You take any number c, any real number c between a and b. At that particular number, at that particular input, the left hand limit should be equal to right hand limit, which is also equal to value of the function. If that is the case, we say that the function is continuous in open interval a comma b. I hope you understood this. Now let us understand the meaning of the continuity of a function in closed interval a comma b. See, when can I say that a function is continuous in closed interval a comma b means, first let me draw a general graph of it. Take a and b on the number line on x-axis and draw some random graph of f of x between a and b. Dear students, first of all, a function is said to be continuous in closed interval a comma b if, first condition, number 1, at x is equal to a, the value of the function, okay na, let this number is equal to f of a and this number is equal to f of b. Okay, now some values. Okay, at x is equal to a, the value of the function should be equal to its right hand limit. Okay, now so that means what? at x is equal to a, the function must be right continuous. Okay, at x is equal to a, f of x must be right continuous. That is the first condition. And second condition is that at x is equal to b, the value of the function must be equal to its left hand limit, which means number 2, at x is equal to b, f of x must be left continuous. F of x must be left continuous. We have checked only at endpoints now. At x is equal to a, it should be right continuous. At x is equal to b, it should be left continuous. And for all the inputs between a and b, it should be continuous. Okay, now number 3, and for all x belongs to open interval a comma b. Okay, now for every input between a and b, f of x should be continuous. And for all inputs between a comma b, f of x must be continuous. Okay, now between a and b, it should be continuous. At a, it should be right continuous, and at b, it should be left continuous. If these three conditions are satisfied, then we say that the function f of x, y is equal to f of x, is continuous in this closed interval a comma b. Then we can draw the graph of y is equal to f of x continuously from a to b, continuously without lifting the hand. Okay, now let us take a simple example to understand this. Here is a simple question. Check the continuity of y is equal to step x, the greatest integer function, in the interval 2 to 3. Whether I can draw the graph of y is equal to step x continuously from 2 to 3 or not, we are supposed to check. Obviously, let us use the graph of it. You will understand it very easily if you draw the graph of it. Here is the input 2 and here is the input 3. Input 1, 2, 3. When input is 2, step of 2 is equal to 2. For all the values between 2 and 3, dear students, for example, you take 2.5. When input is 2.5, step of 2.5 is also 2. Step of 2.3 is also 2. Step of 2.9 is also 2. So it is continuous. Between 2 and 3 also it is continuous. But what if the input is 3? Step of 3 is not 2. Step of 3 is equal to 3. So, I'm sorry. Step of 3 is not 2, open hole, and step of 3 is 3. I cannot draw the graph of y is equal to step x continuously in the interval 2 to 3, from 2 to 3, because exactly at the end point it is having a jump. You can see that. Correct or not? See, at x is equal to 3, it should have been left continuous. But at x is equal to 3, the value of the function is not equal to its left hand limit. Okay, now, so it is not, what is the conclusion? Since step x is not left continuous at x is equal to 3, what we can say? We can say that f of x is not continuous in the closed interval 2, 3. That is the conclusion, dear students. So I hope you understood the simple concept about directional continuity and also continuity of a function in a closed interval. In the upcoming videos, let us discuss continuity in detail on different functions. Okay, now. So see you all in this next video, and I hope you like this video. You have understood the concepts. Do like the video, share it with your friends. Let the channel grow. See you all in next video. Take care.